All right, so let's take a look at Desmos to kind of figure this out. So we can see that we have a period from 0 to 360, right? So you can see that's one full rotation, and we can see that the amplitude is 1, right? So we can see it goes all as high as 1 and as low as -1. Okay, so those are some of the key points on this graph. So now if I change this, the number in front of sine, if I make that, let's say I make it a 5, or let's say I make it a 2. So now that increases the amplitude to 2, right? So it goes all the way up to 2 on the top of the wave, and it goes down to -2 on the bottom of the wave. Okay, and I can also, let's say we change it to 3, right? So now it's going to go all the way up to 3. We can also shorten the wave, right? Let's make it 1/2 or 0.5. So 1 divided by 2. So that would shorten the wave, right? Now the wave is at 1/2 there. Okay. All right. So whatever number's in front, that tells you what your amplitude is. All right. Now whatever number is in front of x determines your period, but it's backwards, right? Remember, everything inside happens backwards. So if I put a 2 in there, you would think that it would stretch it horizontally, but it's actually going to compress it. It's actually going to shrink it by a factor of 1/2. Okay, so that changes the period from being 360 to now the period is 180 for it to make a full cycle. Okay, so every 180 it's going to make that cycle. So if I change it to 3, then it's going to be instead of 360 divided, or instead of 360, it's going to be 360 divided by 3, which will make it 120. Okay, if you look right here, right here, this second, let me see, this second one is where the period ends, right? So we go from here to here. So 120 would be the length of the period if I put a 3 there. All right. So the way to stretch the period is to divide there. So if I put x over 2, that would double. Oops, that's not what I want. Just want x over 2. So if I put, let me do this. So if I put x over 2 like that, that's going to stretch the period. So we can see that now the period's doubled. So we go from 0 to 720, right? So now it's 360 multiplied by 2. Okay. So basically you do the opposite of whatever's inside to 360. So if it's divided by 2 inside, you multiply 360 by 2, and that gets you 720. If it's multiplied by 2 inside, then you do 360 divided by 2, and that gets you the new period, which would be 180. All right. So that's basically how sine works. Now cosine, let me see here. Cosine is pretty much the same idea, except it starts on the y-axis. All right. So the cosine function starts at 1, starts at the top of the wave, right? And so a full period would go back to the top of the wave. Okay, so you can see it's a full period is 360, just like with sine, and the amplitude is 1, just like with sine, right? So it's basically the same exact type of graph. We're going to be doing the same exact thing, except we're just going to be starting at on the y-axis at the top of the wave instead of starting on the origin like we do with sine. Okay. All right. So you can see they're basically the same wave. It's just one is shifted over a little bit, right? So let's make a cosine graph that has a, let's say we have a amplitude of 2. So then I would put 2 cosine x, right? And you can see same thing. All it does is change the amplitude to 2. You can change it to 1/2 or to 3 or 1/3. So all those things are the same, right? So the amplitude works for cosine the same as it does for sine. Okay, and then you can also change the period. So I can change the period by just putting a number in front of x. If I put a number bigger than 1, it's actually going to shrink it by dividing by that, right? So this would make the period, instead of 360, now it's 180, right? Or I could divide by 2 inside, or divide by a number. Let's see. So if I put this in parentheses here and divide by 3, let's say, that's going to actually stretch the period by a factor of 3. So instead of the period being 360, now it's going to be 360 times 3, which is 1080, right? 1080. And so that makes a full period there. All right. So basically, that's how we graph sine and cosine, is just by knowing what the parent function looks like, and then just figuring out what the new amplitude is and what the new period is by just identifying A and B, and then we can just graph that, right? And a lot of times we'll have a combination. So let me just show you. So like here, you might have a change in the amplitude and a change in the period, right? And so we could graph that, because we know we're going to start at 2 on the y-axis because the amplitude is 2. We're going to go down as far as -2 when we get below the x-axis, and then we know our period is going to be 1080. And so we can kind of draw these. We can draw these two first. In between those two, if we divide 1080 divided by 2, we get 540. That's where it's going to dip to its lowest point. And then we'll hit 0 between 0 and 540. So at 270, and then between 540 and 1080 at 810. All right. And then if we scroll out, we see that pattern just happens over and over again, right? It just continues to happen over and over again. And so so that's what a periodic function looks like, is it just repeats the pattern over and over again. Because remember, as our inputs get bigger, our inputs are angles. So all that's happening is our angles are just getting bigger and bigger over time. But as our angles get bigger and bigger, all we're doing is going around the circle over and over again, right? Remember when we were drawing angles, if you go more than 360, you just keep going around again. And so what's happening is you're repeating those same values over and over again with these periodic functions. Okay. All right. Now, we'll talk about secant and cosecant and tangent and cotangent a little bit more in class, and we'll kind of investigate those together. But basically, remember, secant and cosecant are reciprocal functions. So let me just show you those real quickly. So the way to one way to graph those is just to actually start with the cosine graph. So let me get this back, or a sine graph. Okay. So let's go back to we'll do cosine. So secant, if I do secant, it's going to be y equals secant of x, and you know it's a reciprocal function. What you see is, you'll see it's just cosine. Oops, let me just scroll in just a little bit here. It's going to be cosine upside down, right? And so what will happen is, remember we talked about the fact that sine and cosine can't be bigger than 1. So we see that in their graphs, right? They go as high as 1, as low as -1, but they never go past it. Because remember, they're values over the hypotenuse, so they can never be, the numerator can never be bigger than the denominator. With secant and cosecant, it's the other way around, where they can't be smaller than 1. And so you see what happens is they meet the sine and cosine waves at the top of their respective graphs, or the bottom, and then they go the other direction. So it's kind of like a bunch of mini parabolas. And also what happens is, wherever sine and cosine are 0, if you flip that over, if you have the reciprocal of 0, you get undefined. So that's where the asymptotes of secant and cosecant will happen. Okay, so I'll have an asymptote at x equals 90, x equals 270, and so forth and so on, right? That's periodic, so it'll continue and continue. The pattern will continue over and over again. Okay, and if you change these to sine and cosecant, you'll notice it's exactly the same thing. It'll be one over the other. Oops. So sine, and then when I change this to cosecant, you'll see it's just going to be it's going to meet up right on the tips of the sine wave, or the sine curve. Okay. All right. So that's what secant and cosecant look like. And yeah, we'll investigate those more in class. But basically, the way to draw those is just to draw a sine or cosine, or at least kind of like a dotted line or something, just to kind of give yourself the idea. And then just, just make these parabola looking things on the top of each, and you can kind of draw the asymptotes wherever you have these zeros, right? So you're going to have a bunch of these asymptotes. All right, now you can always use Desmos in your graphing calculators to kind of help you out to figure these things out if you're not sure. Definitely Desmos is a great tool to check on, but just make sure you can do it on your own as well, because on the test you won't be able to use Desmos. So you can use your own graphing calculator too, but I think just understanding the patterns here will be real helpful and help you to be more efficient. Okay, and one last thing, let me just show you tangent. So tangent, and I'll show you cotangent real quickly. So tangent and cotangent, the periods are a little bit different. Their periods are actually they happen every 180 instead of 90 degrees. Oops. So tangent and cotangent, remember that tangent is opposite over adjacent, so it could be anything, right? So another let me rephrase that. So opposite can be bigger than adjacent, or adjacent can be bigger than opposite, or they could be the same. So there's not a limitation on how large or small tangent can be. Tangent can go all the way up to infinity, as you can see, and it can go all the way down to negative infinity, as you can see. And so that works either way. And so we know that tangent of 0 is 0 from what we did with our unit circle, and we know that at 90 degrees, that's where we have an asymptote, right? So you can see at 90, there would be an asymptote there because it's undefined at 90, right? Because it'd be 1 over 0. And so every 90 degrees, you're going to have an asymptote with tangent, all right? And it goes up on the right, down on the left. Now cotangent, on the other hand, goes the other way around. The 0 happens at 90, where tangent has an asymptote. That's where cotangent is actually 0, and then where tangent is 0 is where cotangent has an asymptote. Okay, so they kind of go opposite directions. Cotangent goes up on the left, down on the right. Tangent goes up on the right, down on the left. Okay, so they have different end behavior, and really it's kind of not exactly end behavior because it happens over and over again. So it just keeps repeating the same pattern, but within the little within each period, the end behavior is opposite, right? So, all right. So anyway, that's just a real quick overview, and we'll practice on graphing when we get to class. But it's basically with sine and cosine, just all about finding the amplitude in the period, and then you can just trace that out. And then for secant and cosecant, you basically graph sine and cosine, with the respectively, and then you can just draw those parabolas up from each of the peaks and valleys of the sine and cosine graph. Okay, and then tangent and cotangent are just going to be, they're going to look just like this, but as the period changes, they'll either compress horizontally, and then vertical stretching isn't going to have a huge impact because they go up and down forever anyway, but it'll just make them a little more narrower if they're stretched, and a little more shallow if they're compressed. All right, I'll see you in class. Let me know if you have any questions. Kind of a short video, but yeah, I wanted to practice graphing together, and I think showing you on Desmos kind of gives you a good idea of how to do that. So enjoy your weekend.